Hello everyone. In the last video, we have discussed the problems related to single stub matching. So in the last problem, we have the load impedance has 1800 ohm without the imaginary term. But in this problem, we have an imaginary term. So your second problem is a load impedance of 90 minus j 50 ohm. So your ZR is nothing but 90 minus j 50 ohm is to be matched to a line of 50 ohm. That is your characteristics impedance using single stub matching. So what we have to find is we have to find the length of the stub as well as the position of the stub. That means your location of the stub. Already we know the formula for length of the stub and position of the stub. So your length of the stub is given by LT is equal to lambda by 2 pi tan inverse of square root of 1 minus mod k square by 2 into mod k. Either you can use this formula or this formula. You can find out the reflection coefficient and you can use this formula, or directly you can substitute the load impedance and characteristics impedance and you can use this formula. And the location of the stub is given by LS is equal to lambda by 4 pi psi plus this is your phase angle psi plus pi minus cos inverse of k. So once you know the reflection coefficient, you can use this formula. So in the polar form, your k is given by mod k into the psi, that is your phase angle. Or else if you know ZR and Z0, that is your load impedance and characteristics impedance, you can directly use this formula in order to find the location or position of the stub. So your second problem has the imaginary term. It's quite complicated compared to the first problem. So the given data is your load impedance as 90 minus j 50 ohm and the characteristics impedance as 50 ohm. Now, so first we have to find the reflection coefficient, right? So reflection coefficient is given by k is equal to ZR minus Z0 divided by ZR plus Z0. And we know ZR is equal to 90 minus j50 and the characteristics impedance as 50. And divided by 90 minus j50 plus 50. So 90 minus 50 is 40 and 90 plus 50 is 140. So we have the reflection coefficient as 40 minus j50 plus divided by 40 minus 140 minus j50. Now this is in the rectangular form, right? Now we have to convert into polar form. So if you convert 40 minus j50 divided by 140 minus j50 into the polar form, you will get 64.0312 and the phase is minus 51.34 divided by, if you convert 140 minus j50 to polar form, you will get the magnitude as 148.66 and the phase as minus 19.65. So if you just divide this, you will get 0.4307 and the phase is minus 31.69. So your phase angle is minus 31.69 and the magnitude of the reflection coefficient is 0.4307. So we know the determinant of k, that is your mod k, and also we know the phase angle, that is minus 31.69. So if you know the phase angle as well as mod k, you can find the location as well as the position of the stub. So now, so this is angle, right? So we can convert into radian. So you just set the calculator in radian mode and then multiply pi by 180. You will get minus 0.5531 radian. So now once you find the phase angle, we can find the location of the stub. So location of the stub is given by LS is equal to lambda by 4 pi psi plus pi minus cos inverse of mod k. So lambda by 4 pi, your psi, the phase angle is given by minus 0.5531 plus pi minus cos inverse of the reflection coefficient. That is your magnitude of the reflection coefficient is given by 0.4307. So if you substitute in this formula, you will get the location of the stub as LS is equal to 0.1164 lambda. Similarly, in order to find the position of the stub, the length of the stub, LT is given by lambda by 2 pi tan inverse of square root of 1 minus mod k square by 2 into mod k. So we know what is mod k, right? Mod k is 0.4307. You can substitute the magnitude in this formula and you'll get the length of the stub as LT is equal to 0.128 lambda. So this is how we have to find the length and location of the stub in single stub matching if you know the load impedance and characteristics impedance.